Now we have solved this question. This one was done. This one was done in class. We have solved this one in class. I think this question I have given you as your homework, right?
Yes, sir. Yes, sir.
All right. Now the question says two monkeys A and B are moving along the same rope.
Sir, is the answer 4:1?
So 1:1.
The 4:1.
No. Not 4:1 also.
1:1.
6:1.
No, not 6:1 also.
So 1:1.
No. Let us try to understand the problem. It says two monkeys A and B are moving along the same rope. If A moves up with acceleration 10 meter per second per upward and B comes down with 5 meter per second square, then find the ratio of tensions in the strings above point P and below the point P, right, as shown in the figure. Alright. Let us try to understand this question in this way. Whenever we need to find out the tension at any point, what we do actually, we cut the system of the rope somewhere, right? So here I have to find the tension just above and the below the point P. So I will take two segments of the string, right? One segment let us take like this. Let us assume that this segment I have taken. I have cut the string here, and another I have cut the string here. So here the tension on the string is T1 and here the tension of the string is T2. Why the tensions are different? Because now there is a monkey that is hanging here and there is another monkey that is hanging here with that rope. Right. So let us now try to draw the free body diagram of this portion of the rope. You can see that first try to understand that.
Sir, can you please repeat the portions?
Yes, I have cut the string here and here above point P and below the point P. Above the point P the tension is T1 and below the point P the tension is T2. Right, I have to draw the free body diagrams of these two separate segments. Now before drawing the free body diagram of the ropes, if I try to draw the free body diagram of the monkey, can you see that which force is responsible to pull that monkey above? Tension force. Basically, it's not the tension force that is responsible.
Friction.
Yes. If you closely look, that the monkey is holding the rope, so there is some force between the hand of the monkey and the rope, right? That is one type of friction force. We do not know what is friction force till now. We have not studied it. But again, you can assume this to be any type of force. Suppose F. What is this force F? This force F, monkey is applied on the rope and rope is applied on the monkey. Can you say that?
So means action reaction.
Yes, definitely. These forces are action reaction force. Monkey is exerting on the rope some force and the rope is exerting the same force on the monkey. So let us assume this to be F1 on the small upper monkey. It is F1. What is the weight of the monkey that is acting downward? The weight of the monkey actually is mg. And
Sir, the monkey is same.
Yes, that I have to assume here because no other informations are available. So assume the weights to be the same. And what is the acceleration of the monkey? It is upward acceleration.
10
G
per second.
Yes, 10 meter per second square, or I can assume it to be the value of G. Can you draw the
So
free
what have
body
you drawn at that side?
acceleration? This side, whenever you will draw acceleration on free body diagram, do not draw the acceleration inside the body. Always keep the acceleration out of the body, out from the body. Understood? So here I have drawn the acceleration out
Yes,
of
sir.
the body, and let us assume this acceleration is G upward. Can you draw the free body diagram and tell me what is the force F1 in this case? Just write down the equation of free body diagram and tell me what is the force.
2mg. 2mg. 2mg.
2mg.
2mg.
Yes, it is
2mg.
2 mg. I can write down this equation easily. That is F1 minus mg is equal to mass into acceleration, which is also mg. So what is F1? I can say F1 is equal to 2mg. Right? Now let us come to this part of the rope. Which part I am talking about? The portion between these red color lines. Right? Now if I draw the portion here, now you have to tell me what are the forces that I will show on this part of the rope.
Sir, the tensions.
Which tension? Where? Above this point.
Upward.
Yes, the tension T1 will act above
Upwards.
this point, yes or no? Yes or no? If
Yes,
I
sir,
cut
yes,
the
sir.
string, tension will always act away from the string. And just below that rope, what will be the tension here at this point?
The friction.
No, T2. Because the lower portion of the string will have a different tension T2.
Why
And
is it in that direction? Can you say once?
tension is always getting out of the body. That basic property you have studied last class. Do you remember that?
Oh, means both the tensions. Means
Yes, all
both
the
the sides it will
tensions.
get out of the body.
All the tensions will always get out of the body. They cannot get into the body. Is there any other force on that rope?
Mm.
Can
No,
you
sir.
tell me any other force on that rope?
Sir, the friction force.
Yes. Which
The
friction?
normal reaction.
What normal reaction?
With the means monkey's hands.
Yes, the force the monkey is offering to that rope is also F1 and it is downward, yes or no? Because on the monkey, if it is upward, then on the rope, what will be the direction of that force?
Downwards.
Downward. And as
Okay.
the rope is massless, so there will be no weight of the or the mass of the rope. So can you draw? Can you write down an equation for these forces?
Yes, sir.
What equation I can write for
T2
this
plus
one?
F1 is equals to T1.
T2
Yes,
plus
that
F1 is equal to T1. Good. T2 plus F1 is equal to T1. So I can write this expression here. T1 is equal to T2 plus F1. Now F1 I know. F1 is equal to 2 mg. So T1 is equal to 2 mg plus T2.
Sir,
And
can you repeat the first part once?
first
Sir, I was
equation
not in the meeting.
for that monkey.
Yes, sir.
What are the forces on the monkey? Can you see the monkey is holding the rope with his hand. So the rope must exert a upward force on his hand.
Yes, sir.
That force I have assumed to be F1. Downward is weight and the monkey is going up with acceleration G.
So monkey উপর tension act করবে না?
No. The force acts on the hand of on the monkey is actually not a tension force. That is one type of friction force.
Okay.
Right? In a very similar way, I want you to draw the free body diagram of the lower monkey and the this lower segment of the rope. Just in your
Okay.
copy, try to draw them.
Sir, have you taken the first acceleration of the first monkey G because the value is
Yes,
given
the
there?
value is 10. Yes, for calculation purpose, I have taken it G.
Sir, T2 is T2 equal to 3 mg by 2.
Yes,
Sir, is T2 equal to 2 mg by 3 mg by 2?
T2 equal to no.
So please wait, sir. Oh, sorry, sir. Sir, F2. Sorry, I was mistaken. There is F2 equal to 3 mg by 2.
Yes, that may be yes.
Say F2, I think mg by 2, no? The friction force.
So 3 mg by 2.
Let me
It's
calculate.
actually I
I do not
wrong.
remember. I do not remember
It's a
actually.
3 mg.
So 3 mg by 2.
3 mg by 2, sir.
It's mg by 2.
Okay.
mg by 2, sir.
Okay. Let me draw the free body diagram. Now the monkey is here, right? Now the monkey is here, and suppose this is the hand of the monkey, and in which direction the friction force will act on the monkey? Can anyone tell me?
Upwards.
Upward. Yes, upward.
Upward, sir.
Upward. Good. If this friction force is upward on the monkey, suppose it is F2. What is the downward force on the monkey? It is mg,
mg.
and the
mg.
and the acceleration on the of the monkey is also downward.
G by 2.
Downward.
By 2.
G by 2.
G by 2.
So what force equation I will write? Can I write F2? Sorry, mg minus F2 is equal to
mg by 2.
mg by 2. Can I write this one?
Yes, sir. Yes, sir.
So the value of F2 will be mg by 2. Yes or no?
Yes, sir.
So means that opposite to motion, that concept will use that frictions.
Friction? No, I have not used any concept of friction. Look,
So if the
If you-
acceleration was
Yes.
greater than mg, then friction will be downwards.
yes, if the acceleration is
Okay,
less
from the
than
net we are
g,
saying.
yes, if the acceleration is less than g, then and if you
Obviously an upward force.
yes,
is there.
definitely the friction force will be upward. Otherwise, its acceleration will be more than g.
Okay, so. Okay.
Now, in the similar way, can you draw the free body diagram of the lower part of that string? Just
The
tell
T2
me.
equal to F2.
Yes, what are the forces I have to show?
T2 and F2.
T2 is
Yes,
in
T2
which
will be
direction?
equal to F2.
T2 will be in upward direction, and F2 is in which direction?
Downward.
Downward direction F2.
Down here.
There is no other
Yes.
tension lower that, and there is no
No.
weight of that string. So can I straightforward write T2 is equal to F2?
Yes, yes, sir.
And what is the value of F2?
mg by 2.
If I put the value of T2 here, then what will get the value of T1?
That's 5 mg by 2. Huh?
5 mg
Just
by
5.
2. So what is the ratio of T1 by T2?
5 is to 1.
5 is to 1. That should be the answer of this question.
I told that. You told no.
Have you told 5 is to 1? I only...
Sir, I told 5 is to 1.
Okay, I heard about... I heard only
Yes,
4 is
sir,
to
at
1
that
and
time
6
it
is
is
to
4
1.
is to 1. You heard that only.
Yes. I heard 4 is to 1 and 6 is to 1. If it is 5 is to 1, yes, definitely it's correct. Good. Yes.
So
Have you
can it ever be possible that F2
Sir.
will be downwards?
Sir, can you please explain the free body diagram of the first monkey? Why F1 is going just upward and the second is upwards?
If the monkey is going upward and its weight is acting downward, then there must be some upward force. Yes or no?
Yes, sir.
So that is why I have taken this F1 force upward. And what is the magnitude of this F1 force? I have calculated it from the free body diagram equation.
So then why in this case F2 is upwards? In the second case, here also
Again,
the monkey is going downward.
Here monkey is going downward, but if F2 is also downward, then the acceleration of the monkey will be greater than g.
Sure.
Because mg plus something divided by m is definitely greater than g. Yes or no?
Yes, sir.
So that is why I assumed it to be upward again.
So can it ever be possible that F2 will act downwards?
F2 will act.
So what if it
Downwards.
No, actually, if F2 is
Because
downward,
the tension will be loose.
yes, the string can slack, or if the monkey moves on a rod also, then also its acceleration is greater than g. Possible the acceleration, but
Sir,
yes.
sir, if one-moving monkey is placed above the up-moving monkey, then it might be possible.
No, how it is possible if the acceleration is greater than g? I don't think it's possible that acceleration is
Say
greater
it's
than.
semi-absurd, sir.
Yes.
So it would slip, sir.
Yes. Even if
With the
it
force.
slips, its acceleration will be g only.
Yes, and the string will
Right.
never give tension in that
Yes.
direction.
Yes. Definitely. In that case, then there will be no tension, but maximum g. All right. So
Sir,
this was the question
sir.
that we have studied. Yes. Tell me.
So I'm telling that if the down moving monkey is placed above the up moving monkey, so
Then
then
also how
it
it is
might.
possible? Then also how it is possible?
Because if you consider the tension in the downward is more than the means the
I am not
mass
talking
of the
about the
moving
tension.
part is very heavy.
Look,
Sir, if you pull
whenever
a body with a string, then the friction will act down.
look here, string I have separated. I am drawing the free body diagram of monkey separately. Forget about the tension force. Right. So even if the monkey is placed above or below that previous monkey, so it doesn't matter actually. I think
Yes, sir.
that the free body diagram will be the same. Only the free body diagram of the string will be different. Right? Okay. Now come to this question. It says the monkey B shown in figure is holding onto the tail of monkey A, which is climbing up
Sir,
a rope.
sir.
Yes.
Sir,
Yes.
is
Can we say that the tension always acts towards the means fixed end, rigid end?
No. Tension can act anywhere. Whenever you cut a string, at that point you will definitely find a tension.
Away from the free end, we can say. Away
Yes,
from
definitely.
the free end.
Definitely. Not away from the free end only, away from any point. Tension always acts away from a body. Right? So there is nothing special on that free end. Tension always acts away from the body.
না মানে রোপের তো মানে দুদিকেই আছে তাহলে অ্যাওয়ে ফ্রম এ বডি কোনটা বলবো ওটা
দুটোর দিকে away from the body বলবো one second. If this is a rope, there are two ends of the rope. So at this point tension will act in this direction, at this point tension will act in this direction. Both are away from
দুদিকেই
the
অ্যাওয়ে
body.
ফ্রম বডি
Yes. That is why it is at rest.
Yes.
ওকে স্যার and if it's massless net force is zero.
Always zero. If it is massless,
Okay.
net force is always zero.
Okay, sir.
Sir, is this answer like the force is needed to be given is between 70 to 105 Newton?
Yes, good. That should be the answer of
So
this
the
question.
answer is 105 Newton.
No, you have to find a limit for that.
It's a range.
Yes, there should be a lower limit and upper limit. Look, the monkey B shown is holding on to the tail of monkey A, which is climbing up a rope. The masses of the monkey A and B are 5 kg, 2 kg respectively. If A can tolerate a tension 30 Newton in its tail, what force should it apply on the rope in order to carry the monkey B with it? So let us assume that I will draw the free body diagram of the monkey separately, right? So first I will draw the free body diagram of the of this monkey, right? Monkey A, and the monkey is holding the string, right? Here there is only one string, so I can say F is equal to T very easily. If you draw the free body diagram of the string, here you can cut the string anywhere here, and you can draw the free body diagram, and you can see that on this upper portion there is tension, and on this lower part of the string what will be the force? The F force, right? That we have talked the last in the last example, right? So that is why F is always equal to T here, because the string is massless and there is no other string below that point, right? So this is definitely the free body diagram of the
So
string.
no other forces are involved.
Yes,
No other forces are involved.
yes. So only F and T. So F equal to T, definitely you can say. What is the force on the monkey? Here you can, okay. The tail of the monkey should be downward, right? And there is another monkey.
Sir, we can do
Yes, there is another monkey who is.
so rather than drawing can draw point.
Yes, definitely you can draw point, no problem. So F
I
is
have drawn
equal
a
to
box.
T, and what is the weight of this monkey? It is 50 kg, and what is the weight of this monkey? It is 20 kg,
So it
right?
is 5
5 kg.
kg and 2 kg, 50 newtons.
Yes, 50 Newton. Good, 50 Newton. And let us assume that entire system is moving upward with some acceleration. So what equation I can write from this free body diagram? Can I write T minus 70 is,
Equal to 50 plus
T
5.
minus 70 is equals to
Oh yes.
equal to
7a. 7a.
Seven.
7a.
good. That is the equation. Always follow this equation. Left side you will have force and right side you will only have mass into acceleration. Right? Don't change the order. Left side you will have only the force, right side you will have mass into acceleration. If acceleration
Sir.
is 0, make it 0, no problem. Tell me. Yes.
Sir,
Yes. Yes, do you have any doubt? Alright. Now look to the free body diagram of the second monkey.
sir,
Yes, tell me. Can you hear my voice? Can you hear my voice, everyone?
Yes,
sir.
sir.
Yes,
Yes, sir. I can hear you,
Yes,
sir.
sir.
Now look to the free body diagram of the second monkey. For the second monkey, there is a tension force that is offered by the tail of the first monkey. Yes or no?
Sir,
Yes.
sir.
Yes.
So what did you say for in the last 2 minutes? I couldn't hear you.
I have only written the free body diagram equation here. Right? We have not done anything else. This is a free body diagram where the force on this upper monkey is the tension, and the downward forces are their weights, and the system is moving upward with constant acceleration a. So, or at this instant its acceleration is a. I can write down this equation: T minus 70 is equal to mass into acceleration, right? And I have said that I have used the Newton's second law here: F is equal to mass into acceleration. Now look to the free body diagram of the second monkey. Its weight is downward 20 and it has a tension upward. So can I say this tension T prime, and it is also moving upward with the same acceleration a? Yes or no? Because the system is actually moving upward. So can I say T prime minus 20 is equal to 2a?
Yes, sir.
In that case, there is a maximum value of this T prime. So if I have to find the maximum value of a, what is the maximum value of a?
Half, sir.
Can I say it is T prime is equal to 30 minus 20 divided by 2, so that is 5 meter per second square.
So please repeat this part, sir.
Can you understand this equation for the second
Yes, sir.
monkey? Now in this equation, what is the maximum value of acceleration possible that I have to find? So for that I have to calculate the maximum value of T prime.
Yes.
And what is
Yes,
that?
sir.
Maximum value of T prime?
30.
30
30
Newton.
Newton.
30 Newton. I have only placed that value and I have found the acceleration maximum is 5. Why I have got the maximum acceleration? Because in order to find the T max, the maximum tension, can I say it is 70 plus 7 into A max? And what is A max? 5. So what is the T max? The maximum value of tension is how much? Have you got the solution till now?
Yes, sir.
Yes,
Sir,
sir.
I actually found out only this answer.
Yes.
I didn't know
But
about the range.
but it has a lower limit also. Why lower limit? Suppose the monkeys are moving upward, but the acceleration is small, right? It is the maximum acceleration possible is 5. If the monkey is moving upward with 2 meter per second square, also it can, because the tension maximum is 30. If you give it a 10 Newton force in the tail, it will also carry, no problem. What is the minimum acceleration possible here in this case?
So 0.
Zero.
Zero.
Because monkeys are moving upward, and if they are moving upward, the minimum acceleration possible is 0, right? They are moving very slowly with a constant
Yes, very
velocity.
slowly.
Yes, very slowly with a constant velocity, you can say. So I can find what is the tension in that case. Is it
That's
70 or
70.
not?
Yes, sir.
Yes.
70.
So the tension value should lie in between 105 to 70. That should be the answer of this question. If you have
Okay,
any
sir.
doubt, you can ask me.
So I don't understand the minimum value.
You have not got the minimum value?
No, sir.
If the monkey wants to move upward with a very small acceleration, how much acceleration you can assume it to be 0? Then also the lower monkey will move upward with it.
Yes, sir.
So in that case, what is the minimum tension needed? If
70.
you put the 70. If
Yes,
you put
sir,
the
yes.
acceleration 0. So that is why I have said that minimum tension it has to
Okay,
put
sir, I got
70.
it.
Right? If it
It means
if the-
infinitesimally small acceleration.
you can assume 0 acceleration because it is moving with constant velocity. Right? Alright. So I think up to this it is clear to all of us.
Yes, sir.
Let us erase this board. Move to the next part.
So maximum acceleration only we had to go to the equation.
Yes.
Sir,
Yes.
sir, in case of lower monkey, why didn't we consider friction? Why did we directly take tension?
Once again. In case of the lower monkey, yes, you can say, because in case of lower monkey, also if you draw the free body diagram of this, right? Look, it is attached at the lowest point of this tail. If you actually think about this, then the lowest point you will only find that there is nothing else below that string, right? So whatever may be the tension, that will be the friction force only. You can draw the free body diagram of the monkey with this friction force also. You will find the same thing.
So but that will change a bit, no?
No, it will not change. Let us try to
It's
solve.
slow.
Yes, let us try to solve it again. Suppose I am trying to draw the free body diagram of the tail of the monkey. This portion. Right? This portion I want to draw the free body diagram.
Yes, sir.
So at this portion, the upper tension is T prime and the lower tension is equal to F prime, if you assume this to be F prime. Is there any other force on this tail?
The acceleration.
The tail is massless, so whatever is the acceleration, there will be no effect on that.
So please repeat this part, sir.
I have drawn the free body diagram of this part of the tail. The lower monkey
First
is
monkey's tail.
Okay.
upper
okay,
monkey's
yeah.
tail. Upper monkey's tail, yes. So the lower monkey is applied a force F prime. Lower monkey is applied a force by that tail F prime. So similarly, I can say that there will be a F prime downward on the tail of that upper monkey.
The section reaction, okay.
And what is the tension? I have assumed it to be T prime. And there is no acceleration of the part of the string. So I can easily assume that T prime is equal to F prime.
Yes.
Right? Yes. The same thing. Okay.
Okay, okay.
Now comes a very
And all the
important
values
case.
of acceleration are net, no? Resultant.
Always, yes. Resultant means what acceleration? Acceleration is only once. A particle can move only in one acceleration. That is definitely with the effect of all the forces.
Okay.
Acceleration is with the effect of all the forces. Alright. Now there is another very important topic that we will learn today. It's called constraint motion. Why we will learn constant motion, that you have to first understand. Suppose you have a system of mass and pulley, right? Like this. This is a pulley, there is a mass. Suppose there is another pulley, there is another mass. There may be different type of configuration like this. I know this mass, but I do not know their accelerations. So when I will write the equation of motion, uh, not equation of motion, the equation of the forces, then what are the force on this small m? You will see the force on that small m is tension T and downward mg.
Tension and weight.
And wait.
And what is the force on this capital M? This upward tension is what?
2T.
2T. This upward tension will be 2T because of this 2T. Upward tension is 2T and downward
So
tension.
why 2T, sir?
Yes. Why 2T? Can anyone explain that? Why it is 2T?
That double the tension.
Two parts in two segments.
They're attached to two
It's an upper part of T.
strings.
Look, if you draw the free body diagram of this pulley, this shaded pulley, then there will be two tensions upward, both are tension T because this is a single string, and let us
Downward.
assume that downward tension is T prime. As the pulley has no mass, can I say always the net force should be 0?
Yes, sir. Yes, sir.
So can I
Yes.
say T prime is equal to 2T?
So that T prime and that 2T are action reaction.
T prime and 2T, not their action reaction force. Action reaction force occurs
No, the
on
mass,
the same
the
body.
mass.
On the
Yes,
same
if you consider
body.
that of the mass and that of the pulley.
Mass and the pulley. Yes, definitely. This is a one string. So the forces are in this direction 2T on the pulley and upward direction 2T on the mass capital A. Now, if you draw the free body diagram, let us assume this acceleration is A and this acceleration is B. Now,
Sir.
if you yes,
The A to minus 2B.
okay, I will talk about that. But first, let us draw the free body diagram and try to write down the equations. If I draw the free body diagram of small m, upward tension is T, downward is mg, and upward acceleration is A. What equation I will write? Is it T minus,
T minus mg is equals to ma.
ma?
Sir,
Yes.
sir, can you please repeat what you said in the last 2 minutes? I was out
Can
of
you
it,
can you see the free body diagram of small m body here?
Now I can see.
Yes. So if you can see that, I have only written the equation of motion here, equation of forces. What is the force upward T, downward force minus mg, and acceleration is A. So net force equal to mass into acceleration. That only I have written. Can you tell me what is the free body equation for the capital M mass?
Mg minus 2T equal to mb.
Yes, good. It is
So why is it 2T for the big M?
okay. You missed that part. You can
Yes, sir.
see that I have drawn the free body diagram of that shaded pulley. This pulley.
Yes,
Can
sir.
you see that? What are the forces on this pulley? These two tensions will be upward, yes or no? Away from the body? Due to that string, to part of the string. And due to that downward string, the tension is T prime. As the mass is 0 of that pulley, so what is the net force on that pulley always?
T prime equals to 2T.
0. Net force is 0. That means I can say T prime is equal to 2T. Now look, what I am trying to say, actually I have not asked you to find out the value of tension or acceleration A or B, but what I am trying to say that even if I drawn the free body diagrams, I have written the equations, but I could only form two equations, 1 and 2. But in this question, how many unknowns are there actually?
4.
Not 4.
1, 2, 3, 4, 5.
T and A.
T, A and B. These three are unknowns?
Yes, T, A and B.
These three are only unknowns, yes or no?
Oh,
T,
names are
A
given.
and B.
Yes, sir.
M,
Yes, all masses are
M are
given.
definitely given. Small m, capital M are definitely given. So if T, A and B, three unknowns are there and I have only two equations, can you solve this?
No, sir.
No.
No.
No, sir.
So that is why it is needed to write a constraint equation. The extra equation you can always find. The extra equation always can be found by constraint equation. Remember that whenever in your Newton's laws of motion or in further chapters of physics, whenever you will lack one equation, right? More unknowns are there than the equations you have formed. Always think about the constant motion. It will always give you one extra equation.
Say in laws of motion and which chapter?
Most of the chapters in mechanics, right? In later part, work energy power, center of mass, rigid body rotation. So all these chapters will involve these constant motion equations. All right. So is that concept clear? Why we use constant motion equations?
So what is the equation?
We will understand what is the equation. That only our motto to understand that.
So I have a question, sir.
Yes, tell me.
So that for that pulley I have given not toward downwards the T prime.
Yes.
So that T prime is 2T. So can you please once more explain that why for capital M it will be 2T upwards? This is the theory was.
Because tension is always away from the body. For that capital M, can you pull that capital M by tension? Push that capital M by tension, or you can only pull the capital M by tension?
Only pull.
So that is why pulling force is always away from the body. I have said that the basic rules.
Same for pulley.
Yes, same for pulley. Basic rules you never forget that tension always acts outward of the body, out from the body. Have you got this one?
So why it will be same as 2T?
Because the Newton's third law is there. You can see the string part that is connected between the pulley and the mass. I am drawing the free body of that string. What is the force at this point on the string? You have assumed it to be 2T. We have known that it is 2T. If I say that this tension is T double prime, then what is the free body equation for that rope you can write?
T double prime is equal minus 2T equal to 0.
Yes, because the mass of the rope is 0.
Okay, sir.
I think it is clear to all of us.
Yes, sir.
Yes, sir.
Now let us see how do we form a constant equation. Remember, there are lots of ways to form a constant equation, right? Few methods are very lengthy, like differentiation method. Few methods are very easy, like virtual work method. But all these methods do not easily applicable, do not actually solve the question easily in all these cases. But the method that I will teach you can be easily used for all the cases, right? So even if you know what is the way to solve constant motion equation, I hope that a few of you have studied it in lower class physics, that were how to solve the constant motion equations. But just try to learn the method that I am going to teach you, right? It is called the segment method. Segment method, let us assume that I have assumed a very simplified model of constant motion. Let us assume that there is a pulley and a string passes over that pulley, right? So one end of the string is connected here with some body. Suppose there is some body connected here and there is another body connected here. Let us assume that the acceleration of this body is upward and acceleration of this body is downward. When I am saying assume, if it is not mentioned in your question, you can assume it to be downward, it to be upward, or both are downward, both are upward, no matter. You can assume it to be in any direction, right? So that I have assumed that it is going upward, it is coming downward. I do not know what is the value of its velocity or acceleration. Let us assume it is going upward with some velocity v, or rather let us assume that it has moved upward in a small time interval delta t by delta x1 and it has come down by delta x2. It is very easy to understand from this diagram only that delta x1 must be equal to delta x2. Can anyone tell me why I can just say that delta x1 equal to delta x2?
Because length of rope is constant.
Yes.
The length of the rope is constant.
Because the length of the string is constant and it is not slacked, right? That means if the lengths you are
inextensible.
Yes. What is delta
Yes,
x1? Actually, you can see that by this delta x1, you are actually compressing the length of the string this side. Yes or no?
Yes, sir.
By
Yes,
this
sir.
delta x1, you are actually decreasing the length of this segment. And by delta x2, you are actually increasing the length of this segment. Yes or no?
Yes, sir.
Yes. But what will be the increment? That will be the decrement, because the total length of the string should be what? Constant. So in segment method, what I will do, I will break the strings into different segments. Here, how many segments you are noticing in this case?
2 segments.
2 segments are there. Yes, we can
So please
notice
say that x1 is equal to x2.
that I will find. That I will find. No, here by only observation I can say delta x1 equal to delta x2. But sometimes observation is not enough, right? You cannot find the solution by only observing. So then we will need that constant motion equation. How we can solve it? Suppose I have these 2 segments of the string, right? ये जो दो segment दिख रहा है ना, ये left side and right side, there are 2 segments of the string. So I have separated the segments. Look,
Okay.
मैंने इस segment को अलग अलग हिस्से में I have divided these 2 segments. Now you can see that the left side segment that is connected to the pulley, the topmost point of the left side segment, that is connected to a pulley which is fixed. The topmost point of the other segment is also connected with the same pulley which is fixed, right? तो देखो यहाँ पे करना क्या है? There are 4 points. Can you see? There are 4 points of this 2 segment. One, if I talk about only the ends, right? मुझे इनके बीच का कोई भी point नहीं लेना है. We have to only talk about the ends of the segments. So the top end of the strings, they are connected with a fixed pulley. Can I say that their velocities can be assumed to be 0, or their displacement can be assumed to be 0, as they are attached with a fixed part?
So
Yes,
please
sir.
repeat that pulley one.
Because the pulley is at rest, so I have assigned the velocity or displacement of the pulley to the topmost points of the segments. Right? याद कर लो.
If we teleport from this to here,
It's
Yes,
0.
yes.
sir, we teleport the rope from this side to that side.
Yes, we can. You can neglect this part, but again this part will be a constant. देखो, कोई भी स्ट्रिंग का कोई भी एंड अगर किसी बॉडी से जुड़ा हुआ है, just take that velocity of that body to the velocity or displacement of that end of the string. That is the segment method saying. Here, the end of this left part of the pulley, and this is the right segment of the pulley, the top end of the left part of the pulley is connected with a pulley which is fixed. So I can assume the velocity or displacement of the top end of the left segment of the rope is 0. Similarly, the right segment of the string, the topmost part is also connected with the fixed pulley. That is why I have assumed it to be 0. But what about the bottom part? Can I assume that bottom part is connected with this body which is moving upward by a displacement delta x1? Okay, I have assumed this to be delta x2, that to be delta x1, right? So this part has moved up by delta x1 and this part has come down by delta x1. Can I say that?
Yes.
Yes, sir.
Now I will write down an equation. This is 0, so that part doesn't matter. But by delta x2, am I going to decrease that length or am I going to increase that length?
Decrease.
Decrease. So whenever it is decrease, you can put a negative sign for that. Again, I am saying that whenever you will find the displacement or velocity inside the rope, take a negative sign. For the right segment of the string, the upper portion is 0. What about the lower point?
It's expanding.
It's increasing the length, and you can say that whenever you will see the displacement or velocity that is going away from the length, I will take a positive sign for that. Can I say that the
Please
total
repeat this part.
increment and decrement is 0?
Yes, sir.
From there you can say that delta x1 equal to delta x2. So that equation is known as constraint equation.
Can you repeat this part, sir? This length.
You can only see that about the left segment by delta x2, you are going to increase that segment length or you are going to decrease that segment length.
Decrease.
That is why I have put a negative sign for that.
Okay.
For that right segment, if you pull it by a delta x1, you are going to increase that length or decrease that length.
Increase. Right segment. So
Right
increase.
segment. So I have put a plus delta x1, and the net increment and decrement should be 0 because the length of the string is constant.
Okay, sir. Okay, sir. It can be understood normally.
Yes. So that is a method of constant equation that I have written here. Now we will try to understand this method in deep after we solve few questions, right? So let us try to solve few questions for that. Here you will find the equation that I have written here. Now one more thing, that if I can find the relation of delta x1 and delta x2, can I just divide it by delta t and I can say that v1 is equal to v2 also in this case?
Yes, sir.
And if I
Magnitude.
differentiate the velocity, what I will get?
Acceleration.
Acceleration.
Yes. So that way I can find a relation between the accelerations. Now, try to apply the segment method and find the relation between the accelerations A and B here.
Sir, a plus 2b equal to 0.
I'll assume A is upward and B is downward. You can assume A downward, B upward, any direction. No
Okay,
problem.
so give some.
Just take few minutes and draw a constant
This I will give a
equation.
relation.
Yes, only relation is needed. Constant equation only give you relation.
So 1:2.
Yes. Look.
1:2.
Please give some time, sir.
Yes.
So 1:2.
Yes.
So 1:2.
Yes. Yes.
They are in opposite direction.
Okay. Can you tell me how many segments are there here?
4
Three
segments.
3 segments of the same
Three
string.
segments.
Three
There are 3
segments, sir.
segments.
Yeah, one string, 3 segments.
Yes, there are 3 segments only. Look, whatever may be the acceleration of that block, the same acceleration of the pulley will be. Yes or no? Because the pulley and block are connected with a same string. So I can neglect that part of the string and I can say the pulley is also coming down with the same acceleration v.
Pulley or string?
All of them. This entire body is coming down with acceleration v actually.
Because
Now-
that string has only one segment.
Yes, only one segment. Now, can you tell me what will be the velocity or displacement of the topmost point of these 3 segments?
So 0.
All of them,
Zero.
all of them are 0.
Yes,
Yes,
sir.
sir.
What about this lowest point of this first segment?
It goes
Then
up.
A upward, yes or no?
Yes, sir.
sir.
Yes,
For
sir.
the second segment, what is the displacement or acceleration of this?
So B downward.
B down.
B downward, yes, good. And
See,
for
if we
that,
don't know the direction, we can take it anywhere though.
yes, yes.
If we don't know the direction, we can take
You can
it
take it
anywhere.
in any direction. Yes, I have taken it downward. That is why I have put it downward. And what
Yes,
about
sir.
the bottommost point of the third segment?
Say downward B.
Downward B.
Downward.
Good. Now I will write down an equation. Look, 0 I can neglect. So for this A
So this
part,
I am not getting, sir.
which one?
Sir, why we took 3 segments?
This one, and this one.
Then the bottom part will not take.
Bottom part you can take, but that is only one segment. One segment, whatever is the acceleration of the topmost point, the same acceleration will be the bottommost point. Because it is one segment only. So we can neglect always. That block is connected with the pulley. So whatever may be the displacement of the block, pulley will also displace the same thing.
And that's the whole system.
Yes, you can assume this to be a system.
Okay, so after that.
Now tell me, what I will write before A, plus or minus?
Minus.
Minus A, because that is going into the length, right? So minus A.
Yes.
What about this B?
Plus B.
And another B is there.
Plus B.
So you have got your constant equation A is equal to 2B. That is so simple. So we have done this one. Remember, one string, one constant equation. If there are two strings, I will write two constant equations. Three strings, I will write three constant equations. Mostly you will find one or two strings mainly. Now in next question, can you find a relation between A and B here? Suppose A upward, B downward.
Please wait, sir.
The A is to B is equals to 1 is to 3.
Yes, I think.
Take some more time.
So 3A is equal to B. So 3A equal to 2B. Sir?
Yes, tell me.
So 3A equal to 2B.
2B.
So 3A is equal to B.
Yes. Now can you tell me how many strings are there?
2.
There are
Two strings, two.
Two strings. So let us first talk about this string. How many segments are there in this string?
So 2.
So two.
Two segments. Look,
So where 2, sir?
this one and this one. Where do you get any other segment? Yes or no? And that is a separate string. That is another string. Now look, in segment method, you have to consider all the moving parts. Are here only these two blocks moving?
No, sir. That pulley
No,
is
sir, the pulley is also
Pulley is
moving.
also moving. I do not know what is the acceleration of that pulley, but let us assume this to be C. I have taken it downward. You can take it upward, no matter. Now,
Sir, A is upward, so that will be
Yes.
also downward.
yes, definitely you will find the value, no matter. If it is upward, you will find the value negative.
Okay, sir.
Alright?
So
Now-
how did you get that it is downwards?
You can take it upward, that I have said. You can take it upward, but you will find it to be negative. If it is negative, it is downward, no problem. It is a vector, no? Vector you can assume in any
Yes, sir.
direction.
Yes, sir.
Now,
I'm saying how you got it by
yes,
seeing.
okay. I'm just saying that it will be the same because okay, by observation, if you do not understand, then it will come by time, right? Doesn't matter. Now let us come to the first string and its 4 points of the two segments. What will be the accelerations of the
Zero.
topmost points?
Sir, 0.
0.
What about this lowest point?
A.
Sir, A.
Upward or
A
downward?
and C. A is upward and C is downward.
C is downward. Can I write a constant equation for this segment, for this string only?
Yes, sir.
What I will write, can you tell me?
Yes, minus A plus C is equal to 0. C is equal to A.
So C
So
is equal to
minus A plus 0 plus C.
Good. Now come to the second part of the string. Now in second string, there are 4 segments. Let us first come to the topmost point of the two segments.
Yes. That's C downwards.
C.
Minus C it will be.
Downward.
Minus C.
In which
Sir, C
direction?
downward.
Both are A downward, can I say? Because A is equal to C.
Yes, sir. Yes, sir.
Yes, sir.
Okay.
What about this point?
Sir,
One is A
upward.
upwards and one is B downwards.
A upward and B downwards. Now can I write down a constant equation for that?
Yes, sir.
Yes,
Two
sir.
A's will get cancelled, I think.
Okay, so in the first segment,
That's cancelled.
will it get cancelled?
Yes.
No.
Yes.
No, sir.
No.
No,
Look,
sir.
both the
Sir,
accelerations,
-2A.
both the accelerations are going into the length, inside the length. So what I will take?
Sir,
Okay.
minus A and
Minus
Both
2A minus A
minus.
plus B. Minus 3A plus B. So B
Yes,
is equal
and
to
about
3A.
this is also minus A plus B equal to 0. Have you got this equation correct?
Yes, sir.
So
Yes,
what is
sir.
B?
Yes.
B is equal to 3A. Have you got this one?
Yes, sir.
Yes, sir.
Yes.
Yes, sir.
So that method is very easy if you can properly use that. Right? You have
Yes,
to
sir.
understand that.
Sir, say in the second string, how are you considering that the acceleration of the upper parts are A and A downwards?
Because this upper parts are connected with what? Are they connected with this pulley?
Yes, sir.
And what is the acceleration of this pulley?
A downwards.
That is why I have put the A downward for both these parts. Have you
Sir, can
understood?
you repeat
So
the
means we have
last?
to consider the strings separately.
Yes, two strings, two constant equations.
Oh, I had taken it together. I don't know this.
No, that I have said that for each string one constant equation. Yes, tell me if you have not understood any part of this solution.
Sir, the second part, can you please explain? I was disconnected.
Okay, the second part I have taken the second string. Can you see the second string? I have taken two segments
Yes.
of the second string. Yes.
Yes,
now,
sir.
now can you tell me with which one the bottom parts of the second string is connected?
Sir, couldn't get it.
The bottom part, the topmost part. Let us assume this topmost part of this second string. They are connected with which?
Yes, sir.
They
Sir,
are
the
connected
pulley.
with that pulley, yes or no? And what is the
Yes, sir.
acceleration of that pulley? इस पुली का acceleration क्या है? ये जो movable पुली है, इसका acceleration कितना है? What is the
Sir,
acceleration
C.
of that pulley? C. C का वैल्यू हम लोगों ने क्या निकाला A. That is why I have written the acceleration of these 2 points are getting A downward. क्या ये समझ में आया? इतना समझ में आया? और ये
মানে
जो
ওটা এতে কানেক্টেড আছে তো গুলির
हाँ,
সঙ্গে
एंड ये जो लोअर पार्ट ऑफ द सेगमेंट है, इस ये सेगमेंट इस ब्लॉक के साथ कनेक्टेड है.
Yes, sir.
So whatever is the acceleration of that block, that will get attached with that acceleration of that part of the string. What is the acceleration of that block?
Sir, A upward.
Upward. So I have taken A upward here. And this acceleration
Yes.
of this, the end point of that string is connected with that block B. But I do not know what is acceleration of block. I have assumed it to be downward. You can assume it to be the upward also. You will find the same answer with a negative sign. No problem. Now can you write down the equation? This A and this A both are actually going inside the length. Can you see that?
Yes, sir. Both are negative.
Both are negative. This A is also going inside the length, negative. And
Yes.
this B is coming out of the length. I have taken it positive.
Okay, sir.
So these equations basis is that first equation so
Basis, yes. From the first equation,
that
I
the
have
strings
only,
have the same length.
yes. The strings always have a same length.
Yes.
Look now.
And you said no with minus. So what you were saying that with minus value will get
If you take minus, then the value will be negative or not. If you assume B in upward direction. If you assume B to be in upward direction, what will be the value of B you will get? It will be minus 3A, yes or no?
yes.
If A is upward, B is
Yes.
upward, B will get minus 3A. If B is minus
So 3
3A,
is magnitude.
yes. Magnitude will be 3A, but what will be the direction in that case? You have to assume that if it is minus, the actual acceleration of that will be downward.
Opposite of the chosen direction.
Yes, opposite of the chosen direction. Good. Okay. Now look in the next problem. I have slightly modified the situation, and now there is certain angle made by the string with the block. The block is moving with velocity v, right? So whenever you find this type of situation, when the velocities are not, or the displacements are not along the string, in last case all the accelerations or velocities are along which direction?
Along the length of the string.
Along the length.
Along the string.
Yes, but if you do not find in some particular situation the velocity or displacement along the length, you take the component of that velocity along that length,
Components.
and you find the same constant equation that we have used. So can you try
Can
to
you please
find out?
wait?
Yes,
Sir, shall we solve it?
yes. Just try to solve this question. Find the velocity and acceleration. First find the velocity of it. Then I will talk about the acceleration.
Sir,
Yes.
sir, the velocity of block A, VB sin theta.
Velocity of block A, V
Yes,
sin
the
theta.
velocity of block A is v sin theta.
Yes.
Yeah, V sin theta.
V sin theta.
V sin theta.
Yes.
V sin theta.
So please wait, sir. Yes, sir. V sin theta, velocity of A.
Yes. Can you tell me how many segments are there?
The 2 segments.
Two
Two
segments. sir.
segments are there. Good. Two segments are there. Now, if I try to write down the velocity of the ends, what is about the top ends?
0.
Zero.
Zero.
Fixed
Zero.
pulley is there. Let us assume the velocity of A is upward u. I do not know. It may be downward. So I have assumed it to be upward u.
Yes.
What about the velocity of the end of this second segment?
V towards the right.
Yes, v
That's
right.
yes.
But I will not take this v in my calculation. What component I will take?
V sin theta.
V sin theta.
Yes,
V sin
V sin
theta.
theta.
v sin theta component I will take. Now
Yes.
I will write down a constant equation. What about this u, plus or minus?
So that's
Minus.
Minus
Minus.
u. And what about this v sin theta?
So plus.
Plus.
that's out. That's plus.
Out of
Plus.
the length. So that is 0. So you can find u is equal to v sin theta.
Yes.
Right?
So that's
that-
the instantaneous.
Yes, definitely it is instantaneous. Now can we calculate what is the acceleration of that block A?
Yes, sir. Thanks.
At that instant.
Yes, at that instant only.
Sir, it's moving with constant velocity. So is it zero? I know, don't know, just
No,
asking.
no.
Which one is moving with constant velocity? A or B?
Okay, yes, sir, I got it. Sir, it's not constant.
Sir, please give some time, sir. Please.
Yes, yes.
So is it V
Sir, is
cos
it-
theta?
V cos
No,
theta.
no.
Okay. Is theta generated.
So V square by H.
No.
Sir,
Yes. No,
so V
it's
square
not.
by H.
No, it's not V square by H.
Please give us some more time.
Yes.
The acceleration of which body?
A. Acceleration of A.
So V square by H cos cube theta.
Yes, I think that's the answer. V square by H cos theta. Yes. Look, if you know the velocity of A at some instant, I can just differentiate that velocity, can find acceleration. Yes or no?
Yes, sir. Yes, sir.
So if I differentiate this velocity, it will be acceleration. Now this at two part, v and theta. But v is a constant or variable?
V is constant, but theta is
V is
variable.
constant.
Theta
If
is
I
variable.
take v constant, then what is differentiation of sine theta? Can you tell me?
So
Cos theta.
Cos theta.
It's not cos theta, it is cos theta into d theta by dt.
Cos theta by dt.
Yes, sir. With respect to time, yes, sir.
Yes, cos theta into d theta by dt.
D
Now the
theta by
problem
d
is
theta
that I do not know what is d theta by dt. How
So
can
T
I
is
find?
h by tan theta by v.
Yes. So
Sorry,
what
h
is
tan theta
x?
by v.
What is x? This x, I can say that x is equal to h tan theta.
H tan theta.
So what is dx by dt? It is v or not?
Yes.
Can I say it is h sec square theta into d theta dt? Can I write this equation?
Yes.
So
Yes,
from there, can you find this d theta dt and put here? What is d theta dt then?
Yes. V by h
V
into
by h
sorry
cos
v
square
cos
theta.
square theta into h by h.
So I'll put this value here. You will get v square by h cos cube theta. That is the acceleration of A at this instant. Yes, have you understood this one?
Yes, sir.
Sir, can you explain how did you get the value of d theta dt?
Can you see that right angle triangle
Yes, sir.
where the base is x, height is h? So what is the relation between base and height? Can I say x equal to h tan theta?
Yes, sir.
If I differentiate it with respect to time, what is dx by dt? Is this v or not?
Yes, v.
And what is tan theta differentiation? Is this sec square theta d theta by dt?
Yes.
So from there, can I get what is d theta by dt?
Yes, sir.
Yes.
Sir,
Yes.
I found t as a function of theta.
T as a function of theta. How can I find that? Or theta is a function of t. How can I find that?
Sir, t will be h tan theta by v, no? Because v is constant for that.
H tan theta by v. Yes.
So will that not help?
Yes. That, same equation. Yes. Also, you can do one thing. What is this component of v in this direction?
Which direction?
Cos theta.
Perpendicular
Yes,
v cos theta.
V cos
so
theta.
d cos theta.
Do you know the perpendicular velocity?
Hmm.
What is the
Change it.
perpendicular velocity? Can I say perpendicular velocity is equal to L omega? If this is length L. Do you remember the circular motion equations?
Yes, sir. Yes, sir.
Yes, sir.
V equal to R omega. So here R is radius is L and L is equal to H sec theta. Yes or no?
Yes.
So what is omega? Omega is equal to V cos theta by L. You will find the same thing, V by H into cos square theta.
So please repeat
Sir,
this.
how are you considering this circular motion?
Yes, because we have solved this type of question in circular motion. Because if some observer is present here, the observer will say that this is a circular motion, but its radius is changing.
Oh, yes, sir. Yes, sir.
Right? What is the
Yes,
rate
sir.
of change of the radius length? It is V sin theta. And what is the rate of change of the angle theta? The rate of change of the angle theta can be found by this component of velocity, V cos theta.
Oh.
Yes or no? This is the
Yes, sir.
this is the radius vector. Now this component of the velocity, can it change the length of this radius vector?
No,
V cos
sir.
theta? No.
No, sir.
No, sir.
So v cos theta is changing only the direction of this radius vector. So that is why I can say it is v cos theta is equal to L into omega.
Yes, tangential acceleration.
It's not acceleration, I'm talking about velocity.
Yes.
Alright.
Okay, sir. So linear velocity and that angular velocity relation.
Yes. That velocity, that relation we have used. Can we find this one? Try to find the velocity of the
Okay.
block C.
Sir? Sir,
Yes.
so is it 2v cos theta?
No.
V cos theta?
No.
No.
2v.
No.
2v
Calculate
cos
it
theta.
properly. Calculate it properly.
So C is at rest.
I have to find the velocity of C only.
Oh shit.
Sir, is it v cos theta?
No.
So it is v by cos theta. V by cos theta.
Yes, it's V by cos theta.
Sir, please wait.
So v by cos theta.
Sir,
Yes.
you v sec theta.
Yes. Good. Look. There are how
So
many
it is
segments?
v sec theta.
Sir, 2 seconds, sir. Sir, 2 seconds.
So it is v sec theta.
Yes. How many segments are there?
4.
4 segments. What about the topmost points of the velocities?
So 0.
All
Zero.
of them are 0, connected with fixed pulley.
So 2v
What about?
sin theta.
Yes.
2v sin theta.
No. Just see the solution. For the first segment, what is the velocity at the bottommost point?
So v downwards.
V downwards.
For this last segment, what is the velocity of topmost
V
bottommost point? V downward. Now, for this velocity of C, I do not know what is the velocity of C. Let us assume it to be U. Can I assume it to be U upward?
Yes, sir.
Yes,
Okay.
sir.
If U is upward, so what is the velocity of this point? Of this segment? The end point of
Sir,
the second segment?
u cos theta.
U cos theta.
Yes, it is U
Upward.
So which
upward.
part?
But what is the velocity along this string?
Sir, u cos theta.
U cos theta.
U cos
Similarly,
theta.
similarly, what is the velocity at this point?
Sir, u
It's also u cos theta.
means u cos theta.
So it is also U cos theta in this direction.
Yes, sir.
So now
Yes.
can we write down our equation? What about this V, positive or negative?
So v is positive.
Positive. What is U cos theta?
So negative.
Minus U cos theta. Similar is the other two cases. Minus
So can we find the acceleration?
U cos theta. Yes, we can. Plus V equal to 0. So what is V? equal to u cos theta. So what is
See, is
u?
it the same string?
Even if they are different strings, your segments will not change.
Yes.
Even if they are different strings, you will find the same equation for the two strings.
Yes.
Yes.
Right? So that
yes,
does not
I will
matter
find
actually.
the same.
I have considered it as two different strings.
Yes, you will find
Sir,
the
I
same
have a question,
equation.
sir.
Yes, tell me.
See, if I don't consider that u, and in a way I consider the velocity along the string supposed to be one is k1, another is k2. Then
You can
we
do
will
that.
just add a vector sum. Then can we get it?
Yes, definitely. You will find the same value for this too.
So can you show once? I have done that way. I am not getting it actually.
That way it had not coming. That's the problem.
Yes,
No,
along the
I'm
string. Look,
Problematic in that way.
no. Look, along the string, if you take the velocities, always remember then that you cannot take the component of a component. Suppose.
No, I'll not be taking component. I will be just.
Yes, you are
I'll
taking
get the
component.
resultant at the
Suppose.
last.
No, look, you are actually taking component. If you say that in this direction, suppose the velocity is x, and in this direction, suppose the velocity is y, right? Then while you are adding the velocities, what you are doing? You are taking the component of x along this direction, you are taking component of y along in this direction, and then you are adding.
Yes.
Yes,
Yes.
but that you cannot
Yes.
do because x and y are itself component of the original velocity.
And they will add up to the same velocity.
Yeah. No, if x and y are component of the same of a original velocity, you cannot take the component of x and y to find the original velocity.
Okay. So, but I'm saying that I'll
Look,
just add them.
if suppose this vector is 10, right? If you break the vector 10 into these two vectors, which are suppose
6 and 8, suppose.
Yes, 8 and 6, right? Then you say that I will take component of 6 along this line,
Yes.
right? And I will take component of 8 along this line,
Okay.
right? So if you take
So, but
component,
if I add them, I'll not be getting 10. Sir,
Yes.
I'm not taking components. I'm just adding them.
yes, if you are adding, actually you are not when you are adding these two vectors, if you add these two vectors, then these horizontal components will get cancelled out if they are having the same magnitude, right?
Yes.
When you are adding them, you are getting this to be v and this to be v also, right?
So what's wrong with that? I'm still not getting.
If this is v, this is v, actually you cannot add these two vectors. Look, these two are actually the same vector. Why I will add these two? Can I say that
আমি বলছি
velocity?
কম্পোনেন্ট কে মানে আমি একটা ভেক্টর আছে আমার কাছে ওটাকে আমি কম্পোনেন্টে ভাঙলাম তাহলে যদি কম্পোনেন্ট গুলোকে অ্যাড করি তাহলেই তো আমি রেজাল্টেন্টটাই তো পাবো ওটা বলছি আমি
এই ভেক্টরটাকে তুমি একটা এদের কম্পোনেন্টসে ভেঙেছো তো, বাট আমি কি এই ভেক্টরের ইউটাকে আমি যদি এদিকে ভাঙি, আরেকটা কম্পোনেন্ট তো ইউ সাইন থিটা থাকবে,
হ্যাঁ থাকবে
তাই না? আর এটার আরেকটা কম্পোনেন্ট ইউ সাইন থিটা থাকবে। এবার তুমি বলো,
তাহলে তো কমপ্লিট হচ্ছে না না।
হ্যাঁ, এবার যদি তুমি শুধু ইউ কস থিটার কম্পোনেন্ট এটাকে নাও আর এটার ইউ কস থিটার কম্পোনেন্ট এদিকে নাও, তাহলে কি তুমি ইউ পাবে? হোয়াট অ্যাবাউট ইউ সাইন থিটা?
ও নিলে সবই নিতে হবে না?
নিলে তো তোমাকে, সেটাই তো আমি এই एग्जांपलটাতে বোঝাতে চাইছিলাম যে যদি सपोज मेरे पास ये 10 न्यूटन वाला वेक्टर है और इसको मैंने 8 और 6 में ब्रेक कर दिया, तो मैं क्या सिर्फ 8 का कंपोनेंट लेके 10 बोल सकता हूँ?
नहीं सर, ओके
है ना? If you take component of u sin theta, you will find the same thing. But that will be difficult, right? Why I will always
no,
take.
sir, I thought that way. So it
Yes.
struck me first only.
Always
I did
take.
it
Remember,
simple way.
always take the component of the original vector. Don't try to take the component of the components. Then you are going to miss some other component, and you will not find the Correct answer. Yes, that is a very good question. If you have understood the constant motion, then definitely you will be able to solve this question. Two rings A and B can slide over two vertical rods. One string starts from the ceiling, passes through ring A and ends at ring B. If ring A is pulled down with constant velocity V, then find the velocity of B at this given situation. Let us assume this angle is theta at this instant. क्या सिचुएशन को विजुअलाइज कर सकते हो? ये एक रिंग, इफ आई पुल दैट रिंग डाउन, तो इस रिंग का मोशन क्या होगा? व्हाट विल बी द मोशन ऑफ दैट बी?
So the
Upward.
two
That
rings
will
are
move
connected.
Yes, tell me.
Upwards.
মানে দুটো রিং কিছু দিয়ে মানে জোড়া আছে।
এই স্ট্রিংটা রিং এর ভেতর দিয়ে পাস করে এখানে আটকানো আছে,
ওহো,
রাইট? You need to find this upward velocity of this ring B.
So will the answer be B into 1 minus cos theta by cos theta?
Yes, yes, good. That is the answer.
so please wait.
So is it B minus B cos theta by 1 plus cos theta?
By 1 plus cos theta, it should be only cos theta.
So what?
Sir, V minus V cos theta by cos theta.
Yes, yes, yes.
Okay. Sir.
Take to the answer. So u cos theta divided by 1 minus cos theta.
ইউ
Hello.
তো বার করতে হবে, তুমি আবার ইউ cos theta কেন বলছো?
In the
Unit বের করতে হবে, sorry. Sir, v into 1 minus cos theta divided by cos theta.
Yes, yes, yes. Good.
Okay, sir, আমি
Look, if I solve this one, how many segments are there here? Can you tell me? How many
Two
segments are
segments.
there?
উল্টো।
Only two segments are
Two
there.
segments.
Yes. So now let us try to write down the velocities. What is the topmost point velocity? 0. What is the velocity
Zero.
of this point of the first segment, the bottommost point?
V downwards.
Downwards.
V downwards.
Okay, now
out.
come to the second segment. What is the velocity of this first point?
V cos theta inwards.
B cos inwards.
Yes.
V cos theta
So,
inwards.
V downwards, so I can say it is V cos theta inward.
ওটা v sin theta না? ওটা v
না,
sin
v
theta
cos
হবে
এটা থিটা তো,
হ্যাঁ স্যার v sin theta
So to cos theta.
cos
v
theta হবে,
এটা
sir.
থিটা হলে v cos theta হবে না?
oh.
And what about this velocity if it is u? Then what
Sir,
about
u
this
cos theta.
u cos theta.
u cos theta
cos
u
theta?
cos
It's
theta
also going into the length. So if I write down the equation, then what about this u cos theta plus or minus?
Sir,
তো দুটোই মাইনাস সেকেন্ড কেসে দুটোই মাইনাস
Yes, both the
Second
minus
case এ
because
দুটোই
both are
minus.
going into the length. So minus u cos theta minus v cos theta plus v is equal to 0. So what is u cos theta? That is v into 1 minus,
1 minus cos theta
cos theta. So u is equal to v into 1 minus cos theta by cos theta. Done. So now we will use these constant motion equations to solve few questions. Right now till now we have only found the relations between accelerations. We have actually found the constant
এবার ভ্যালুস
equations.
বের করতে হবে তো
Now we will use that constant equation to find the values. Let us assume this one. This question talks about these three masses, and I need to find you the acceleration of all these three blocks. Right? Let us assume the acceleration of
in
m
terms of m
in terms of
m and g
g will only come, m will cancel out. Okay. Can you see the free body diagrams of the body that we have drawn
The
here?
acceleration a is g by 2.
Yes, good. It's very simple to draw these free body diagrams. Whatever you have solved, you just try to see the solution. It's a very conventional way I'm doing the solution.
The acceleration b is 4. Acceleration b is mg by 4.
G by 4, yes, G by 4.
G by
Equations I'm writing 2t minus mg is equal to ma. This equation is t minus mg is equal to mb.
তো 2mg হবে না ওটা
কোনটা 2m 2m
স্যার যেটা বি ও সরি স্যার আই
3mg minus t is equal to 3mc. Now you can see a, b, c and t. 4 unknowns are there. So we are short of one equation. Can we find one constant equation with ABC? Suppose the
Sir, is the acceleration of c is mg by 3g by 4.
yes 3g by 4. Yes, good. Now let us try to find a constant relation with ABC. If let us assume that the pulley is moving down with acceleration c or say x, right? So I can first write down the constant equation for the first string where the upper segments are at rest. This is moving down up with a, this is coming with x. So readily we can say that a equal to x. For the lower two segment of the string, I can say that this lower point.
Sir.
Yes.
So can we say for the first means right hand side you have given the x. So can we
Yes.
say that to be c minus b?
Why to complicate things? Which one x? This one. How we can say c minus b?
Yes, sir.
How we can say c minus b?
It means b is upwards acceleration,
No,
c
no,
is
that
downwards.
has
So
no
means
way.
I'm just finding the resultant.
No. In that way you cannot do that resultant. These
You
are
can't
two
do.
different bodies. Right? You cannot do that in
Why?
this way. Don't complicate things. It's very simple to understand the constant equation. I have solved it.
Oh, that is within the system.
Yes. So what I can say that minus 2a minus b plus c equal to 0. Can I write this equation here?
Yes, sir.
So c equal to 2a plus b. So that is another equation. 2a plus b equal to
Please
c.
repeat the right side 2 equation. So right side 2.
This equation.
right string. Yes, sir. Please repeat that.
These 2 points, the topmost points are connected with a pulley which is coming down with A.
X, no.
X equal to A, that I have calculated here.
Okay, okay.
And the bottommost points we have assumed to be upward B and downward C. Can I write
B
down
and
this
C,
equation?
Yes.
2A plus B equal to C. Okay.
Yes.
Now you have these 4 equations, and if you solve it, this solution will be definitely a lengthy process. But what you will get, A will be G by 2, B will be G by 4, and C will be 3G by 4. I think that should be the answer of this question.
Send T.
Yes, I got it now.
Yes, and if you calculate the value of T, it will be 3mg by 4.
Sir, I have a question. So why is that 2T and T means? Can you say once?
That we have already discussed. That if you talk about this pulley, then what is the free body diagram of this pulley? In this lower side there are 2 tensions,
Okay, okay, sir.
and
got
upper
it,
side
got it.
there is T prime. So can I say T prime is equal to 2T?
Yes, sir. Action, action.
Okay. Now there is another way to solve this question. That is why it is known as Atwood's machine. Right? Let me show you that another way to solve this question. It will take few seconds of time. Okay. Let us assume that instead of this complicated situation, we have this simple situation. Forget about that complicated situation. Just look to this simple situation of masses M1 and M2. Can you calculate what is the tension T on this topmost pulley? If this tension are T and T, then this tension will be 2T, yes or no?
Yes.
Yes, sir. Yes, sir.
Can I calculate what are the tensions T here? Just let us, here, if the acceleration of this M1 is A, can I say the acceleration of M2 will be same A downward?
Yes, sir.
Yes, sir.
So what equation I will get? I will get T minus M1G is equal to M1A. Just see what I am writing. If you feel that
Yes,
it is
sir.
not
Yes, sir. M2G
okay with
minus
this,
T is M2A.
M2G minus T equal to M2A. Now I will solve for the tension T. I am not going to find acceleration here. I am going to find the tension here. So I will multiply the upper equation with M2,
Yes.
right? And the lower equation I will multiply with M1. So that I can cancel A. Yes or no? So if I calculate T, you will get T into M1 plus M2 is equal to twice M1 M2G.
So M2 minus M1 no T?
No, no.
No, sorry. M1 plus M2.
So what is T is equal to 2 M1 M2 divided by M1 plus M2 into G?
Yes.
And what is 2T? Is it 4 M1 M2 by M1 plus M2?
Yes.
Why I have done this process? Now look, can I replace this entire situation
Yes, with
by
this case.
a mass
The right side will be
equivalent?
4M.
By a mass equivalent, where this mass equivalent is nothing but 4 M1 M2 by M1 plus M2. Can you see that?
Yes.
So what is this mass equivalent? It is 4 M1 M2 by M1 plus M2. This equation is very much useful in this type of pulley problems. Let us see how we can solve the given question by this expression.
So just wait a minute.
Yes.
Pulley problems. Yes, sir.
Yes. Now can you tell me what is the equivalent mass for this left hand pulleys? Here?
Right hand pulley.
Yes, for the right hand side pulleys, what is the equivalent mass?
Yes, sir.
Just calculate it.
So 3m.
Yes, it is 3m. Now the system has two masses. One is m, another is 3m. So what is the
Yes.
equivalent mass of this system now?
So that's so please wait, sir. So
Again
that's 3m again, I think.
Again
3m.
3m. So can you tell me what is the tension on this part of the pulley at the topmost point?
3mg.
3 mg. Now if we know this tension 3 mg, what will be this tension, these two tensions?
3mg. So that will be 3mg by 2.
3 mg by 2. What will be tension on these two strings?
3mg by 4.
3mg by 4.
3mg by 4.
3 mg by 4.
Sir, I have a question, sir.
Yes.
So there, at the top it's 3mg, and just below it at the right, so it is containing another pulley that will not affect. So it will just be
No,
distributed.
this two, if this tension is T, this tension is T, this is 2T. So if this is 3 mg, this will be 3 mg by 2, 3 mg by 2, this will be 3 mg by 4, 3 mg by 4. Now you know what is the
Uniform.
tension and you know what is the masses. Then can I find the accelerations of the blocks easily?
Yes.
Yes or no?
Sir, how is it that here the equivalent mass is 3m?
4 into m1
4m1 m2.
2
by
divided
M1 plus
by m1 plus m2. Can you calculate this one?
Okay, sir.
So do you
Yeah.
understand how I have solved this question?
Yes, sir.